In this video, we're going to look at an oscillating capacitor problem from IsaacPhysics. So the question reads, a capacitor with capacitance C is attached to an AC voltage source, which gives a voltage of V equaling V0 times sine omega t. If there is no resistance in the circuit, what is the magnitude of current flowing at t is equal to a specific value? So first of all, I'm first gonna draw a electrical diagram of what happens in the setup. So we have a variable source like this, and then we have a capacitor in the middle like so. Like this, and it has electromotive force, that's AC, that's alternating. We have a capacitor C, capacitance C, and we know that we're given C is equal to 330 microfarads. V0 is equal to 12.0 volts, and omega, the angular frequency, is equal to 5,720 radians per second. And we're asked what is the magnitude of the current flowing at t is equal to 3.42 seconds. So first of all, we know that when a capacitor is connected to an AC source, current flows through it because there's no charge buildup. And there are a lot of approaches, I think, to solving this problem. The one that I'm going to use is to think about the fundamental situation of what this circuit entails. So if we think about the most fundamental ideas of what a capacitor is, well, we know that capacitance is defined as the number of charge per unit voltage, and so we know that the charge accumulated on the capacitor is going to be equal to capacitance times the voltage, and we are interested in knowing what the magnitude of the current is. So to find the magnitude of the current, we know that the current is defined as the rate of change of charge. So by differentiating the expression for charge, which is the capacitance multiplied by the voltage, we know that the capacitance is going to be a constant value, but the voltage is changing. So we take the derivative of the voltage expression, we get CV0 times omega times cosine of omega t. So therefore, the current at 3.42 seconds is going to be the capacitance, which is 330 times 10 to the power of minus 6 times 12 times 5,720 times cosine of 5,720 times 3.42. And all we need to do is put that into our calculator and make sure that it is in radian mode and key in the values. So I'm just gonna do that very quickly to see if the values match up. So cosine of 5,720 times 3.42, we get a value of minus 21.7 amps. And we're asked for the magnitude, so the magnitude is the absolute value of that. It's going to be 21.7 amps. I mean, the value seems reasonable enough. It's about the same magnitude that I've been expecting. So let's see. Yeah, that's the correct answer.